This is Heliox, where evidence meets empathy. Independent, moderated, timely, deep, gentle, clinical, global, and community conversations about things that matter. Breathe easy, we go deep and lightly surface the big ideas.
So I want you to imagine for a second that you hold the ultimate anchor to a massive historical timeline. I mean, you are holding the definitive proof of when human beings first arrived in the Americas.
Right. The holy grail of archaeology.
Exactly, the Holy Grail. A site that literally rewrote the textbooks, won over the harshest skeptics out there, and forced the entire scientific community to just abandon its most fiercely protected paradigm.
It's a huge deal.
It really is.
Yeah.
But then imagine discovering that this incredibly important site might actually just be, well, a 14,000-year-old pile of river garbage.
Oh, man. I mean, that is just the kind of revelation that sends a cold shiver down the spine of anyone who studies prehistory.
I bet. It's terrifying, right?
Utterly terrifying. Because, you spend decades building these incredibly complex models of human migration.
Right.
You're mapping out genetics, you're tracking linguistics, and it's all anchored to this one definitive point on the map.
Yeah.
And then somebody comes along, looks at the dirt a little closer, and realizes the anchor is dragging.
Yeah, the anchor is completely dragging. And today, we are looking at that exact anchor. Welcome to the deep dive. We are diving into the human colonization of South America, and we are focusing our lens entirely on a legendary site called Monte Verde II.
Down in the Lake District of southern Chile.
Right. And our guide through this whole disruption is this newly published 2026 paper from the journal Science. It's by Todd Surivel and a whole team of researchers. And honestly, what they've done here is nothing short of an archaeological earthquake.
No, absolutely. It's a complete paradigm shift.
But okay, to really understand the shockwaves here, I feel like we have to look at the fortress they just hit, We need to talk about the Clovis First paradigm.
Right, because for a very long time, basically the entire latter half of the 20th century Clovis First wasn't just some casual theory. It was the undisputed law of American archaeology.
Like, you do not question it.
You do not. The narrative was just incredibly clean. The idea was that during the last ice age, sea levels were so low that this massive land bridge formed between Siberia and Alaska, Beringia.
Right, the Bering Land Bridge. We all learned about that in school.
Exactly. And the story goes that the first humans walked across that bridge, waited for these massive continental ice sheets to sort of part and form an ice-free corridor, and then they just funneled down right into the heart of North America.
And they left a very specific calling card, right? Like the Clovis points.
Yes, the Clovis points. These are these beautifully crafted, fluted stone spear points. And, we find them scattered all across North America, and they consistently date to around 13,000 years ago.
Okay, so 13,000 years ago.
Right, so the archaeological establishment basically drew a hard line in the sand. 13,000 years ago was the absolute ceiling. The rule was no human being was in the Americas before the Clovis people, period.
It became total dogma.
Mm-hmm.
I mean, from what I understand, if you were a young archaeologist and you, say, found a site that you thought was 14,000 or 15,000 years old, you weren't just met with a little skepticism.
Oh, no. You were actively marginalized.
Yeah. Your funding dried up, your papers got rejected, you were basically laughed out of the room.
It was a brutal academic environment for anyone challenging that timeline. But then, starting in the late 1970s and moving through the 80s, this American archaeologist named Tom Dillehay started excavating a site in southern Chile.
Right, near a small creek called Chinchihuapi.
Exactly. This is Monte Verde II. And the data coming out of that site was simply impossible according to all the established rules.
Because it was too old.
Way too old. Dillehay's team found evidence of a human settlement securely and, repeatedly radiocarbon dated to about 14,500 years ago.
Which is, that's 1,500 years before the Clovis people supposedly even invented their signature spears up in North America?
Yes.
And Monte Verde is practically at the bottom of South America. I mean, geographically, that just breaks the whole ice-free corridor narrative, doesn't it?
It shatters it. If people were already hanging out all the way down in Chile 14 and a half millennia ago, they didn't just casually stroll down through the middle of the continent through some ice corridor.
Right, they had to have taken a different route.
They did. It forced this massive, really painful reckoning in the field. It pushed scientists to start seriously considering
the coastal migration theory. Sometimes they call it the kelp highway hypothesis.
The Kelp Highway, I love that name.
It's a great visual. It's the idea that early humans didn't walk overland at all, but came down the Pacific coast in boats. They were exploiting marine resources, eating kelp and shellfish, and just moving way faster than walking would ever allow.
And Monte Verde II became the gold standard that validated that whole shift in thinking.
It became the anchor.
Okay, but what really fascinates me here is the preservation. Because Monte Verde wasn't just like a random scatter of a few stone tools, right? Can you paint the picture of what Dillehay's team actually pulled out of the dirt back then? Because the level of detail is what made everyone finally believe it.
Yeah, the preservation is just stunning. So the site is located in a peat bog, and peat bogs are incredibly special environments. Because they are completely waterlogged, they create an anaerobic environment.
Maybe no oxygen, right?
Exactly. Oxygen is almost entirely cut off. And normally it's bacteria relying on oxygen that break down organic matter. So when you remove the oxygen and you add in the natural tannins that are just sitting there in the peat, you essentially stop the clock on biological decay.
Wow. So you literally get a time capsule.
A phenomenal time capsule. I mean, Dillehay's team found things that archaeologists usually only dream of finding: perfectly preserved wooden tools, architectural elements that they interpreted as like the timber foundations of hide-covered tents.
Tent foundations, that's incredible.
Right, complete with these little wooden pegs driven into the ground to hold them down. And they found chunks of preserved animal meat, fossilized bones of extinct megafauna, specifically gomphotheres, which are basically these ancient elephant relatives.
Elephant relatives in Chile. Wild.
They found human footprints in the clay. They even found quids of chewed seaweed.
Wait, chewed seaweed from 14,500 years ago.
Yes. You can literally see the teeth marks.
The level of like ethnobotanical detail there is just wild. It really is like finding a perfectly preserved 1980s mixtape in a time capsule that was definitively sealed in the 1950s.
That's a great way to put it.
You look at it, you test the tape, you confirm it's absolutely from the 80s. And you suddenly realize your entire understanding of when that technology even existed is just wrong. The physical evidence is so tactile, so undeniably human that you just can't ignore it.
And trust me, the scientific community tried very hard to ignore it for a long time. But the radiocarbon dates on that wood and that organic matter were so consistently old, and the preservation was so spectacular that the resistance just eventually broke.
They had to give in.
They did. In 1997, this blue ribbon panel of the most skeptical, staunch Clovis First defenders actually traveled down to Chile.
Like a group of archaeological judges.
Pretty much. They went to Monte Verde, they looked at the trenches, they examined the artifacts in the collections, and they officially capitulated. They published a consensus stating that Monte Verde II was real, and it was 14,500 years old.
Wow. But science is never completely settled. Even after the Pope of Archaeology gives his blessing, there are always those people who look at the data and feel a little sense of unease.
Oh, there always are.
Because you read through the historical literature, and there were always these quiet doubts just sort of lingering in the background.
There were, and it's really vital to understand what those doubts were because they lay the exact groundwork for Surivel's new investigation. While the consensus held strong on the surface, a minority of geologists and archaeologists harbored these deep reservations.
What were they worried about?
Well, some pointed to local reservoir effects.
Okay, let's break that down for the listener, because reservoir effects can totally skew our perception of time. How does that actually work in this context?
Right, so radiocarbon dating relies on measuring the decay of carbon-14 in an organism after it dies. Organisms absorb carbon-14 from the atmosphere while they are alive, but if you have an environment where ancient, dead, carbon-like carbon from old limestone bedrock dissolves into the local water supply, things get messy.
Because the plants drink that old water.
Exactly. Aquatic plants or animals that drink that water will absorb that ancient carbon. And if a human then eats those plants or animals, or if the ancient carbon saturates the soil, it can make a freshly dead sample look thousands of years older than it actually is.
Okay, so the environment itself could have been tricking the carbon clock. But wait, what about the wood? They dated a lot of wood, right? They aren't eating the wood.
Right, and that brings us to the old wood problem, which is honestly a massive headache in archaeology. Imagine a huge ancient tree dies and falls into a riverbed. It sits there, perfectly preserved in the mud, for, say, 5,000 years. Then, a group of hunter-gatherers comes along, finds this nice dry piece of driftwood and throws it onto their campfire. If an archaeologist comes along millennia later and radiocarbon dates the charcoal from that specific campfire, the lab results will say the fire occurred 5,000 years earlier than it actually did.
Because the carbon clock started ticking the second the tree died, not when the humans actually burned it.
Exactly. You are dating the death of the tree, not the human event.
That is a huge distinction, and I know some paleoclimatologists were looking at the pollen and the plant remains from Monte Verde and saying, wait a minute, this doesn't look like an Ice Age ecosystem at all.
Yes. The pollen record suggested a much warmer, drier environment, something that is characteristic of the Holocene, which is our current geological epoch that started about 11,700 years ago.
Not the freezing Pleistocene.
Right. It didn't look like deep Ice Age flora. But again, these were minority voices. The paradigm had shifted, the panel had spoken, and Monte Verde was the new king.
Which sets the stage perfectly for what happens next. If you want to challenge a 50-year-old, heavily defended, universally accepted consensus, you cannot just go back and argue over the shape of a spear point.
No, you won't get anywhere.
You have to change the game entirely. And that brings us to Todd Surivel and his team. They didn't go back to find more artifacts, did they? They went back to read the dirt.
They approached Monte Verde II not as a human habitation site first, but purely as a geological formation. They spent their time systematically sampling 9 different cut banks.
And cut banks are just those naturally exposed vertical walls of dirt along the creek.
Exactly, like a cross-section of the earth. They sampled those, as well as a nearby gravel quarry. And their singular goal was to independently reconstruct the geological history of the entire Chinchihuapi Valley.
Because, if you don't intimately understand the physics of how that specific river behaved over the last 20,000 years, you have absolutely no business trying to explain how a human artifact ended up buried next to a piece of chewed seaweed.
That is the literal foundation of geoarchaeology. The human story is entirely captive to the geological story.
Okay, let's get into the dirt.
Yeah.
We need to do a deep dive into the stratigraphy, the study of these geological layers. Surivel's team maps out the valley, and they identify this really complex sequence, but there are 2 main players we really need to keep straight here.
Right.
The first is what they call SU1, or Stratigraphic Unit 1.
Right. SU1 is the bedrock of this story, figuratively speaking. It is the older foundational dirt layer. Geologically, it's a regional glacial outwash deposit from the late Pleistocene.
Glacial outwash, meaning stuff left behind by glaciers melting.
Exactly. During the last ice age, these massive glaciers in the Andes were just grinding up rock and pushing immense volumes of sand, gravel, and silt across the landscape as they melted. That sediment forms SU1. It built up to form the higher, older terraces that flank the creek valley today.
Okay, so if you are standing down in the valley right now, SU1 is the older, higher ground rising up on either side of you.
Yes. Now, pay really close attention to what sits at the very top of this older SU1 layer. Because as the glaciers retreated and the climate briefly stabilized, these dense, temperate rainforests grew right on top of this glacial outwash.
Making a forest floor.
Right. Trees died, organic matter decayed, and shallow, stagnant bogs formed. This created sublayers, which the researchers call SU1B and SU1C, that are just absolutely packed with ancient wood, charcoal, and this dark, rich organic clay known as gitcha.
Gitcha. Sounds messy. And when they run radiocarbon tests on the wood from this high, ancient layer.
The dates are incredibly consistent. They come back right in that 14,000 to 15,000-year-old range. It is undeniably late Pleistocene dirt holding an immense archive of naturally occurring late Pleistocene wood.
Okay, so I've got a mental picture. SU1 is the high ground, and it's absolutely full of naturally dead, deeply ancient wood. Now let's look at the second major player here, which is SU2.
SU2 is the Jungle layer. It is technically an inset alluvial terrace. An inset is the really key word here. Well, it doesn't stretch across the entire landscape like the massive glacial outwash of SU1. Instead, SU2 is nested inside a trench that was carved down into the older layers. It sits right in the bottom of the creek valley.
And this is the critical detail for everyone listening.
Yeah.
SU2 is the exact layer where Tom Delahay's team found all the famous Monte Verde II artifacts.
Every single one.
The seaweed, the gomfo their meat, the stone tools, the wooden tent pegs, all of it was pulled straight out of SU2.
Precisely. So we have SU1, the older, higher banks, packed with natural ancient wood. And we have SU2, the lower, younger channel, holding the artifacts.
Now, when you read Surivel's paper, there is a massive geological red flag regarding how these 2 layers interact. They state that the boundary where SU2 touches SU1 is an erosional contact.
Yes, an erosional
I
contact.
need you to translate that, because if one layer of dirt just sits next to another layer, shouldn't they just sort of fade or blend into each other over time? What does erosional contact actually mean in terms of missing time?
Let's use an analogy. Imagine geologic history as a towering stack of newspapers, right? Delivered one per day for centuries. In a perfect, undisturbed geological sequence, you can read the newspaper from January 1st, then pick up January 2nd, then January 3rd.
Right, the dirt just keeps stacking up in perfect chronological order.
Right, that is a continuous depositional sequence. But an erosional contact means that halfway through the stack, someone came along with a blowtorch and incinerated 100 years' worth of newspapers.
Oh, wow.
And then they immediately stack yesterday's newspaper right on top of the charred remains of the 1800s.
The blowtorch in this case being the river.
Exactly. An erosional contact means the Chinchihuapi Creek became incredibly active at some point in the past. The water flow increased dramatically, maybe due to a massive climate shift, and the stream acted like a saw.
Just cutting right through the landscape.
It cut deeply down into its own bed, actively scouring out and washing away massive amounts of the older SU1 dirt. It eroded the landscape. Then, thousands of years later, the water dynamics changed again, and the creek started depositing new sand, the SU2 layer, directly onto that scoured-out surface.
So when you look at the physical line in the dirt where SU1 meets SU2, you aren't looking at a smooth transition of time at all. You are looking at a geological scar.
A huge scar.
You have 15,000-year-old dirt sitting flush against dirt that could be entirely modern, with a massive ghost of missing time right between them.
That is the crux of it. The dirt holding the artifacts is sitting right up against the dirt holding the ancient wood, but they are separated by an unknown, potentially massive gap in time.
And trying to date missing time has to be a nightmare. I mean, you can't radiocarbon date dirt that washed into the Pacific Ocean thousands of years ago.
No, you can't date what isn't there.
You need a marker. You need nature to provide an absolute undeniable timestamp that locks the stratigraphy into place. And amazingly, the Andes Mountains provided exactly that.
This is where Surivel's team moves from basic geology to high-level forensic tephra chronology. They found the Lopue tephra.
Tephra being the scientific term for volcanic ash.
Yes. So, while sampling the older SU1 layer, the high banks around the valley, the team identified a distinct 5-centimeter thick band of volcanic ash sitting near the top of the sequence. They labeled it layer SU1D.
Okay.
Now, volcanic ash isn't just gray dust. Every volcanic eruption is the result of a specific magma chamber emptying at a specific point in geological time. As magma stews in the earth, it crystallizes, concentrating these rare trace elements in the remaining liquid.
So cooking up a specific recipe.
Exactly. When it blows, the resulting ash carries a chemical signature that is as unique as a human fingerprint.
So you can put that ash into a mass spectrometer and just read the barcode.
That's exactly what they did. They analyzed the trace concentrations of elements like zirconium, niobium, thorium, and hafnium. And the barcode matched perfectly with a known catastrophic eruption from Volcan Michimahuda, which sits about 160 kilometers away from Monte Verde.
And because geologists have already studied that specific volcano and mapped its ash clouds all over southern Chile, we know exactly when it erupted.
We know it with incredible precision. The Michimahuida eruption that produced the Lopue tephra occurred exactly 11,000 years before present.
Exactly 11,000.
It is a regional chronostratigraphic marker. It is an absolute fact. If you find that ash in the dirt, you are looking at the ground surface exactly as it existed 11,000 years ago.
Okay, let's lay out the trap that this ash springs on the Monte Verde timeline. Think about the geometry here for a second. Surivel's team finds this 11,000-year-old ash sitting near the top of the older SU1 dirt. It forms a neat layer right over the bogs that hold all that naturally dead 14,000-year-old Pleistocene wood.
Right.
That makes perfect chronological sense. The forest dies. The wood sinks into the bog 14,000 years ago. 3 millennia pass. A volcano erupts 11,000 years ago and blankets the wood in ash. The timeline holds up perfectly.
It holds beautifully for the older dirt.
But where is the ash in the SU2 layer? The inset terrace. The dirt that is actually holding the chewed seaweed, the gomphothère meat, and the stone tools.
It is entirely absent. There is not a single trace of the Lopue tephra in the SU2 dirt.
It's just missing, completely missing.
And that absence is devastating to the old paradigm. Because remember, the original Monte Verde investigators claimed that the human campsite The artifacts in SU2 were 14,500 years old.
But if that human campsite was truly sitting there in the valley 14,500 years ago, then 3,500 years later, when Volcan Mishmahuida erupted and blanketed the entire lake district in 5 centimeters of ash, that ash should have covered the campsite too.
Exactly. The ash should be layered directly over the artifacts in SU2, just like it is layered over the old wood in SU1. But it isn't there.
It's like a detective arriving at a house where someone claims a car has been parked in the driveway for a whole week. But yesterday, there was a massive snowstorm that covered the entire neighborhood in a foot of snow. The detective looks at the car, and there's no snow on the roof or the windshield. The only logical conclusion is that the car wasn't parked there during the storm. It was driven there afterward.
That's a perfect analogy. The absence of the ash proves definitively that the SU2 dirt and the artifacts inside it were not there 11,000 years ago. They hadn't been deposited yet. The supposed 14,500-year-old human occupation was not present to be blanketed by the 11,000-year-old ash.
But Surivel's team didn't stop at a missing ash layer. I mean, they didn't just want to prove SU2 was younger than 11,000 years. They wanted to know exactly when the river actually deposited that dirt.
Right, they wanted a firm date.
So they deployed one of the most fascinating dating technologies we have, optically stimulated luminescence, or OSL.
OSL is brilliant because it bypasses organic material entirely. You aren't dating a dead piece of wood. You are dating the geological event itself. You're dating the dirt.
I love OSL because the physics behind it sound basically like magic. Walk us through how a single grain of sand can tell you how long it's been buried.
It comes down to quantum mechanics and crystal lattices. The dirt in the Chinchihuapi Valley is full of quartz and feldspar sand grains. Now, these grains are constantly bombarded by low-level natural background radiation from trace amounts of uranium, thorium, and potassium in the surrounding soil.
Okay, so natural radiation in the ground.
Yes. And when this ionizing radiation hits the crystal lattice of a quartz grain, it knocks electrons out of their normal state.
Like kicking a ball out of a valley up onto a hill.
Exactly like that. And while most of those electrons fall right back down immediately, some of them get caught in... Exactly, the battery is charging. But the moment that grain of sand is exposed to sunlight, even just a few seconds of direct sunlight as it rolls down a riverbank, the light provides just enough photon energy to evict those electrons from their traps. They immediately fall back to their normal state, and the battery is instantly drained to zero. The geological clock is completely reset.
Wow. So to date the dirt, Surivel's team takes a metal tube, they hammer it deep into the SE2 dirt layer in the dead of night, or maybe under an opaque tarp, completely shielding it from the sun.
Right. They can't let any light hit it.
They pull out this core of sand, wrap it up tight, and take it to a specialized darkroom laboratory. What actually happens in the lab?
So in the darkroom, they expose those ancient sand grains to a very specific wavelength of laser light. This controlled light triggers all the trapped electrons to escape all at once.
And what happens when they escape?
As the electrons fall back to their ground state, they release their stored energy as a faint glow, a luminescence. By measuring the exact intensity of that flash of light and comparing it to the known background radiation of the site, physicists can calculate precisely how many years have passed since that sand grain last saw the sun.
It's an incredibly robust metric. I mean, it's literally reading the light trapped in the stone. So they run the OSL dating on the SU2 sand, the exact sand encasing the Monte Verde artifacts. What does the luminescence actually tell them?
The results completely shattered the old anchor. The OSL dating proved that the SU2 sand was last exposed to sunlight between 8,600 and 2,800 years ago.
Let's let that sink in for a second. The dirt that holds the artifacts at its absolute oldest limit was deposited 8,600 years ago. That is the Middle Holocene. We are thousands of years removed from the Pleistocene Ice Age.
It perfectly aligns with the missing ash. The SU2 layer couldn't have 11,000-year-old ash on it because the SU2 layer didn't even exist until 8,600 years ago. The river hadn't built that sandbar yet.
But this creates a massive paradox. And I think this is where the mystery really hooks you. We have definitive proof that the dirt holding the artifacts is only 8,600 years old. But the original researchers' radiocarbon dated the wood and the gump of their bones found right next to those artifacts, and the lab result came back as 14,500 years old.
Right.
And let's be clear, Dillahay's team didn't forge those numbers. The wood is genuinely, chemically, 14,500 years old.
The dates are real. The wood is old.
So how do you get a 14,500-year-old stick buried inside an 8,600-year-old sandbar.
To solve that paradox, we really have to look at the true culprit of this entire deception, which is the mechanics of the Chinchihuapi Creek itself. We need to reconstruct the crime scene.
Let's do it. Walk us through the newly proposed timeline of this valley, step by step, starting in the deep past, 15,000 years ago.
Okay, 15,000 years ago, we are in the late Pleistocene. Glaciers have retreated, leaving this vast outwash plain. A dense, cold, temperate rainforest covers the landscape. Trees live, trees die, and they fall into shallow, stagnant, anaerobic bogs,
Just piling up.
piling up over thousands of years. An immense amount of naturally preserved wood and organic matter builds up in this soil. This is the SU1 layer. There are no humans required in this step. It's just nature archiving dead wood.
So the warehouse is fully stocked with old inventory. Then, 11,000 years ago, volcanic Chinchihuapi erupts. It drops the Loe Tefra, sealing that ancient forest floor under a solid layer of ash. The timestamp is locked.
Yes. Now we move into the early Holocene. The climate changes drastically. It gets much warmer and drier. The wetlands dry up. Because the water table drops and the stream dynamics shift, the Chinchihuapi Creek goes on the offensive.
What does that mean, on the offensive?
It starts aggressively cutting downward, slicing a deep trench right through the volcanic ash and right through that ancient buried layer of 14,000-year-old Pleistocene wood. It excavates a miniature canyon.
Ah, so it's carving out the empty space where our younger SU2 layer will eventually sit.
Exactly. Fast forward to about 8,600 years ago. The climate stabilizes again. The creek loses its cutting power and instead starts depositing material. It starts laying down new, fresh sand and gravel in the bottom of the trench it just dug. This new filling is our SU2 layer.
The layer that the OSL dates confirmed is only 8,600 years old.
Right, but rivers don't just flow in a straight line. As the creek is slowly filling up the bottom of this trench over thousands of years, it is meandering. It is swinging back and forth, hitting the walls of the trench. It is actively undercutting its own steep banks, the older SU1 banks that are towering right above it.
And what happens to an undercut bank? It collapses.
It collapses, and what is stored in those towering older banks? Massive amounts of perfectly preserved 14,000-year-old Pleistocene wood, ancient peat, and the bones of extinct animals that died naturally in those bogs millennia earlier.
Oh, man.
As the creek undermines the banks, this ancient material tumbles down and washes directly into the new Middle Holocene channel.
Let me try a mechanical analogy here to sort of wrap our heads around this. Imagine a slow-moving conveyor belt in a massive Amazon warehouse. That belt represents the Chinchihuapi Creek 8,600 years ago, just laying down new sand.
Okay, I'm with you.
Now imagine that conveyor belt runs intimately close alongside a towering, wildly unstable, poorly stacked shelving unit. The shelves are packed exclusively with 14,000-year-old vintage inventory. As the belt hums along, it bumps the shelves. The old boxes tumble down, crashing onto the belt, mixing perfectly with the brand new items currently moving down the line. If you are an archaeologist standing at the end of the conveyor belt, just looking at the pile of stuff that drops off into your lap, you see a modern artifact sitting right next to a 14,000-year-old box.
Yes.
And if you assume they were both placed on the belt by the same person at the exact same time, your entire timeline is fundamentally ruined.
That is a phenomenal way to visualize redeposition. The creek was a geological blender. It was constantly churning up and recycling 14,500-year-old natural garbage from its own banks and just burying it in fresh 8,600-year-old sand.
And then the humans show up.
Right. Human beings, Middle Holocene hunter-gatherers, walked along that riverbed between 8,600 and 4,000 years ago. They camped there, they dropped their stone tools, they spat out their chewed seaweed. And the river kindly buried those recent human artifacts right alongside the ancient recycled wood.
So when the original archaeologists dug their trenches in the 1980s, they found the tools right next to the old wood. They radiocarbon dated the wood. It came back as 14,500 years old, and they understandably but catastrophically assumed the stone tools had to be the exact same age. They completely fell for the creek's deception.
They fell victim to taphonomy.
Taphonomy?
It's the study of how organisms decay and become fossilized, the complex laws of burial and decay. It can be incredibly tricky.
But I need to play devil's advocate here for a second, because Delahaye's team wasn't naive. They looked closely at this wood. They argued vehemently that a sluggish, low-energy creek like the Chinchihuapi wasn't capable of moving giant logs and burying them in a way that looked like deliberate human architecture.
They did argue that, yes.
They interpreted this wood not as random fallen branches, but as structured tent pegs, stakes, and shelter foundations physically driven into the earth. How does Surivel's team explain away complex, supposedly human-made wooden structures?
That is the ultimate test of the redeposition theory. Surivel's team knew they had to address the architecture, and they did so with one of the most elegant, painfully simple observations in the entire paper.
What did they do?
They didn't rely on abstract computer models. They put on their boots, stepped out of the excavation trenches, and just walked up and down the modern Chinchihuapi Creek today to see how it behaves right now.
The present is the key to the past. What did they actually see?
They observed that the modern creek is still doing it. Despite being a relatively small, sluggish stream, it is actively transporting considerable amounts of wood in its channel today. Heavy logs, branches, twigs, all being moved, waterlogged, and buried by the natural hydrodynamics of the stream.
So the energy argument completely fails. The creek can move the wood.
Yes, but here is the most astonishing part. They photographed modern tree branches sticking vertically straight up out of the channel gravels. They look absolutely identical in every physical respect to the pieces of ancient wood that were previously excavated and interpreted as human-made tent pegs by the original investigators.
Wait, are you saying the river just naturally plants sticks vertically into the mud? That sounds counterintuitive. You'd think water would lay everything flat.
You would think so, but fluid dynamics are incredibly messy. Think about it. A waterlogged, heavy branch washes down the stream. The heavier end gets wedged into a little crevice in the gravel bed. The current pushes against the lighter end, levering it upright.
Okay, I can see that.
And then the stream flow slows down, drops its sediment load, and quickly buries the base of the upright stick in sand, locking it perfectly in place. It happens all the time. But to an archaeologist who is desperately expecting to find the remains of a Pleistocene tent, a vertically wedged stick looks exactly like a tent peg.
Wow. It's just confirmation bias written right into the geomorphology?
Exactly. The architecture is just natural river debris.
Okay, this is a massive paradigm collapse. The wood is recycled garbage from the banks. The tent pegs are just vertically wedged river sticks. The dirt itself is thousands of years too young. But there is one piece of evidence we haven't dismantled yet, and it's the most important piece. The tools.
The stone tools, yes.
The stone points. You can't argue that a perfectly shaped, beautifully knapped stone spear point is just river debris. Humans made those. Doesn't the very presence of those tools tell a story?
Oh, it certainly does tell a story. But again, it's not the Pleistocene story we've been telling for 50 years. To understand the true story of the human occupation, we have to look at the artifacts themselves and the data surrounding them. And Surivel's team points to a massive, glaring red flag in the original Monte Verde II radiocarbon data that researchers have actually been quietly sweating over for decades.
What's the red flag?
The spread of the dates. When the original researchers radiocarbon dated all the various organic materials they claimed were part of this single human campsite, the resulting dates didn't neatly cluster together at all. They spanned a massive, unexplainable range of about 2,700 years.
Wait, what?
Yeah. The oldest dates they assigned to the human occupation were around 16,300 years ago, and the youngest were around 13,600 years ago.
Hold on. Let's think about the logic of a hunter-gatherer campsite for a second. The original claim was that this was a brief, single-event occupation. A band of people camped on the creek bank for a season, maybe a year or two, and then moved on. How on earth can a seasonal camping trip leave a 2,700-year carbon footprint?
It can't.
Did they just keep the same campfire burning uninterrupted for 3 millennia?
It is entirely illogical from an archaeological standpoint. If a group of humans occupies a site for a short time, they are generally cutting down living brush, or at least recently dead wood, to build fires and shelters. The radiocarbon dates from that single event should cluster tightly together.
Right, maybe spanning a few decades or a century at most, allowing for some margin of error.
Exactly. A 2,700-year spread isn't an error margin. It's a completely different geological epoch. a spread that huge perfectly matches the statistical profile of a redeposited, jumbled riverbed. It is exactly the random assortment of ages you would expect if a river was slowly eroding thousands of years' worth of natural forest accumulation from an older bank and mixing it all together into a new sandbar.
So the dates themselves are literally shouting at us that this is a geological accumulation of dead matter, not a momentary human event.
Exactly. And beyond the dates, there is an environmental alibi. The paper discusses paleofire records.
Let's talk about that. What do the fire records show?
Well, humans are fire makers. We always have been. Even small hunter-gatherer populations leave a trace on the landscape through fire, whether it's campfires or intentionally burning brush to manage ecosystems and hunt game.
Right.
If there were humans living, thriving, and building complex tent villages in this specific valley 14,500 years ago, you would expect to see microscopic evidence of them in the broader environmental record.
Like charcoal dust settling into nearby lakes.
Exactly. But when paleoclimatologists take high-resolution sediment cores from regional lakes covering that alleged early occupation period, what they actually find is a massive, distinct lull in fire activity.
The landscape was just quiet.
Quiet. The environment strongly suggests human beings were simply absent from the region at that time.
Which brings us back to the physical stone tools. Let's do some typological forensics. Let's look at the actual shapes of the rocks they found down in the dirt. We have what are called lanceolate bifacial points, which are essentially leaf-shaped stone spear or dart points, worked on both sides.
Beautifully made.
Yeah. We also have a highly polished slate perforator, which looks like a tool for punching holes in hides. And we have these fascinating matte-finished spheroids, which are stones that have been artificially shaped into perfect spheres, possibly for use in bolas for hunting.
Right, weapon stones.
For 50 years, these tools were viewed as these bizarre, isolated Ice Age anomalies. Why was that?
Because nothing else in South America looked quite like them at 14,500 years ago. They didn't fit any known Pleistocene technological tradition. They were orphans in time.
Just totally out of place.
Exactly. But Surivel's team points out that if you stop trying to force them into the Ice Age and instead fast forward the clock to the exact time frame that the OSL dating gave us for the SU2 dirt layer around 8,600 to 4,000 years ago, in the Middle Holocene, these tools are not anomalies at all.
Let me guess. They fit right in somewhere else.
They fit in perfectly. These exact types of tools, the leaf-shaped points, the polished slate artifacts, the stone spheroids, are utterly ubiquitous in Middle to Late Holocene shell midden sites right there in the surrounding coastal and riverine regions of southern Chile.
Okay, for the listener, what exactly is a shell midden?
A shell midden is essentially an ancient refuse heap left by maritime adapted people who heavily relied on ocean resources. They would eat massive amounts of shellfish, and over centuries, the discarded shells would build up into huge mounds.
Like ancient trash dumps.
Right. Archaeological sites like Conchal de Piedra Azul and Puente Kilo 1, which are located relatively close to Monte Verde, are classic examples. These sites are securely and indisputably dated to around 6,000 to 4,000 years ago.
And when you excavate those sites, what do you find?
You find the exact same lanceolate points. You find the exact same slate perforators. You find the spheroids.
Wow, so the Monte Verde tools aren't weird, experimental, 14,500-year-old prototypes created by the very first humans to ever see the Andes.
Not at all.
They are perfectly standard, run-of-the-mill, culturally established, Middle Holocene hunter-gatherer artifacts.
They are the standard toolkit of the people who lived in that region thousands of years later. A band of these Middle Holocene people walked along the Chinchihuapi Creek maybe 6,000 years ago. They camped on the sandbar, they dropped a few points, they spit out their chewed seaweed, and the river kindly buried their recent trash right alongside the 14,000-year-old recycled wood tumbling out of the banks.
It is just an incredible confluence of geological coincidences that created the perfect illusion. The anchor was just a heavy rock tied to a ghost.
That's beautifully said.
So we have to pull all of this together and look at the monumental implications of this paper. Because if Surivel and his team are right, and honestly, the mountain of evidence, from the missing ash to the OSL dates placing the dirt in the Holocene, to the physics of the meandering creek, to the regional typology of the stone tools, I mean, it all forms an incredibly tight, compelling case.
It is a devastatingly thorough deconstruction. They didn't leave any stone unturned.
If they are right, then Monte Verde II, the site that single-handedly broke the Clovis First model, the site that forced us to imagine fleets of early humans paddling down the Pacific coast, is not 14,500 years old. It is likely only of Middle Holocene age. roughly 8,200 to 4,200 years old.
The implications for the entire field of American archaeology are just staggering. We have to completely rethink the timeline. Now, it is absolutely crucial to state a caveat here.
Yes, please do.
This paper does not mean that humans weren't in the Americas early.
Right. We aren't resurrecting the ghosts of the 1980s Clovis First defenders. That ship has still sailed.
Correct. Since Monte Verde broke the ice back in 1997, other pre-Clovis sites have been discovered that have much more secure geological contexts. For example, the fossilized human footprints found in the White Sands region of New Mexico are incredibly compelling evidence of a human presence deep in the Pleistocene. So the idea that people were here early is still very much alive.
But what this does mean is that scientists can no longer use Monte Verde II as the ultimate unyielding constraint.
Exactly. For decades, geneticists building complex molecular clocks to track human migration, or archaeologists tracing physical migration routes, were totally chained to Monte Verde. If you built a genetic model that suggested people didn't reach South America until 13,000 years ago, you had to throw your model away no matter how good the math was, because Monte Verde existed. You had to force your data to fit the 14,500-year-old anchor in Chile.
And Monte Verde forced the coastal migration theory to the absolute forefront, because if people were in Chile that early, they had to have taken a biological highway. Walking overland through jungles and mountains would have simply taken too long to get there by 14,500 BP.
But with Monte Verde no longer anchoring the timeline, the coastal migration theory loses its biggest, oldest, and most foundational piece of evidence. And suddenly, interior migration routes, the idea of people slowly, generation by generation, moving overland through the Americas, adapting to new environments at a more measured pace, become highly viable again.
The timeline has relaxed.
The pressure is completely off.
The anchor has been hauled up. We are adrift again, but honestly, in the best possible way, because now we have the freedom to draw a much more accurate map of our own history. And it's a profound testament to the scientific method. You can never stop testing the foundation. You have to go back. You have to bring new technology like OSL and mass spectrometry to old dirt. You have to independently verify. You have to read the geology, not just the artifacts.
It proves that in archaeology, the context is just as important, if not more important, than the object itself. A stone tool without its geological context is just a cool rock.
Just a cool rock. And that leaves us with a final provocative thought for you to mull over as you go about your day. Think about that anchor. Think about the sheer weight of scientific consensus.
It's heavy.
If the most secure, universally accepted, heavily vetted, externally validated archaeological site of the last half-century was essentially an accidental magic trick played by a meandering creek and some falling dirt, how many other chapters of our ancient human history are written on the equivalent of shifting sands? What other foundational truths of our past, the deeply held narratives we accept as absolute, immutable fact, are just waiting for a new team of scientists to come along, look at the landscape with fresh eyes, and read the dirt a little differently?
It certainly makes you wonder what paradigm is going to collapse tomorrow.
It really does. Thank you for joining us on this deep dive. Keep questioning the dirt beneath your feet. Heliox is produced by Michelle Brucker and Scott Bleakley. It features reviews of emerging research and ideas from leading thinkers, curated under their creative direction with AI assistance for voice, imagery, and composition. Systemic voices and illustrative images of people are representative tools, not depictions of specific individuals. Thanks for listening today. 4 recurring narratives underlie every episode: boundary dissolution, adaptive complexity, embodied knowledge, and quantum-like uncertainty. These aren't just philosophical musings, but frameworks for understanding our modern world. We hope you continue exploring our other episodes, responding to the content, and checking out our related articles at helioxpodcast.substack.com.